class. Welcome to lesson 5.4. Here we will continue to talk about logarithms, just more properties of logarithms. And before I talk about logarithms, I'm going to give you a few properties of exponents. So we have this property for exponents when we have the same base. So sort of multiplication corresponds to addition. We also have this property where division corresponds to subtraction. And it's easy to see if you just plug in some numbers, like 5 squared is 5 cubed will equal 5, or 2 plus 3. Right, if you have time, you can verify that in a calculator if you want to do that by hand. Or like 5, let's do 5 cubed over 5 squared. That's basically like 5 times 5 times 5 over 5 times 5. Those cancel out and we get 5, which does in fact equal 5 to the 3 minus. Right, so this doesn't prove it, but it does suggest these formulas do hold. The reason I mention these formulas is because now we are going to learn the corresponding formulas for logarithms. For logarithms, it's a similar idea. Multiplication will correspond to addition. Division will correspond to subtraction. So the formulas for logarithms are the following. So we have a log base a, and then we plug some m and some n in this multiplication. Inside of the log will equal log a of m plus log a of n. Okay, and similarly we do m over n inside of the log. Then we can break it up as log a m minus log a n. Okay. The reason why they are true is simply because, well, this is true and logarithms are the inverse of exponentials. Okay, so let's just start with some examples, some easy examples, and we'll slowly get more difficult. Let's compute log base 18 of 18 times 324. So luckily this was already broken up as a product. Sometimes you have to factor it yourself. But using the formula, you do log base a of the first thing plus log base 18 of the second thing. And now we can just calculate this using the knowledge from 5.3. These numbers are the same, will equal 1. Now this may take a little bit of thinking, but 18 squared does in fact equal 324. At least I think it does. Let me check that in a calculator. Yeah. Okay, so now we can use another property of logarithms that we learned, where we can, well, these are inverses, so that will just equal 2. The whole thing equals 3. So this formula is useful. It may look complicated, but breaking it up as a sum actually makes it easier to calculate. Okay, and sometimes you encounter examples where you don't have any numbers. Say you're just dealing with natural log of wg. Well, if you break that up, that's natural log of w, it's natural log of g. Okay, and then I'll recall from last lecture we mentioned the fact that log base b of a to the x equals x log b of a. So we'll see a few more examples dealing with this in the homework here. So for example, we may need to simplify log base 10, or excuse me, log base c of r to the minus 4. Let's deal with that. Well, using the formula, we could do minus 4 log c of r. Right, or we say we want to simplify this. Something I think we simplified last lecture. We could rewrite the cubed root as an exponent of 1/3. Now using the property, you bring the exponent down. Okay, should continue with some more examples. Say our base is r, and now we have a division inside of the logarithm. Say it's d over 5. Well, by the formula, you do log of your base of the first guy, and then minus log, use the same base of the bottom guy. Okay, so now that we're more comfortable using these properties, let's use them all at once. Let's simplify the following. The log of base b of p to the 4th. Maybe simplify isn't the right word because I'm kind of making it more messy. Expand is maybe a better word. Let's expand this logarithm. Log base b, p to the 4th, q to the 6th, m to the 5, b to the 9. Okay, so let's think of this as a division. Firstly, we could use the division rule first. So using the division formula, we do log b of the top minus log b of the bottom. Okay, and now we can use the product rule here. So maybe I will color code this here. Let's do the top here in green. Let's do the bottom here in red. So we do the top part. And then we do the minus the bottom part. Okay, so looking at this green part, this is now a product inside the logarithm. So now we use the product formula for this green part. We have log b of p to the 4 plus log b of q to the 6. Okay, then we expand the red part. We use the product formula, so we log b of m to the 5 plus log b to the 9. Okay, now we use the exponent formula where we could bring these exponents down, and then we are finally done expanding this logarithm. So we bring the 4 down, we have 4 log b p plus 6 log b q minus 5 log b of m minus 9 log b of b. Okay, and we can even simplify this. The bases are the same, so those will cancel out. Okay, so the last step, we were just bringing the exponents down. Okay, now we can simplify. I'm just going to use black now. So we have 4 log b of p, cannot simplify that. 6 log b of q, cannot do anything with that. 5 log b m, and then just minus 9, because these guys canceled. And then we expanded the logarithm into a sum or difference. Okay, let's look at a few more examples. Say we have natural log of 7 over 4x to the 4y. We want to expand this logarithm. Well, we could use the division rule. So log of the top minus log of the bottom. Okay, now we notice that the bottom is a product, so we will use the product rule. Log of the first thing plus log of the second thing plus log of the third thing. Okay, so now we could just could bring this logarithm down. We get minus 4 log x minus log y. So in the last step I distributed the minus sign and I brought this exponent down. An exponent inside of a log can be pulled out front. Remember that property. Okay, maybe one more example. Let's do log base c of the 6th root x to the 5 over y to the 6. So if we want to expand this as a sum or difference of logs, I think it's best to think of it like this. Instead of a 6th root, we could think about it as being raised to the 1/6, means the same thing. So first we bring the 1/6 down, and we're left with 1/6 log c x to the 5, y to the 6. Okay, now we use the division rule, and we do log of the top minus log of the bottom. And now we just do the exponent rule. Bring the exponents out front. Okay. Cool. Okay, and now we have been dealing with logarithms like this, and we've been expanding them, but we could also go in the other direction. We could start with, say, a logarithm that looks like this, and we can rewrite this as a single logarithm, right? So if we want to rewrite a sum of logs as a single log, first we have to pull any of these coefficients back into the exponent place. Essentially, we're just doing the same thing in the reverse order, right? So if you look at these examples, see if you can follow it going in the reverse order. So if I put this 1/2 back into the exponent place, and I put this 3 back into the exponent place, we get this. And now we can use the product rule. Right, or sometimes instead of raising it to the 1/2, we use the square root symbol. So remember, the log of a product is the sum of the logs, so we're just using the formula in the other order. try to look at a problem with minus signs. Say we have log x to the 5 minus 2 log square root x cubed. We want to rewrite this as a single logarithm. Well, first we have to put this 2 back into the exponent place, and luckily the square and the square root will cancel out when we do that. Okay, so we have log x to the 5th minus log x cubed. And now using the division formula, that equals log of x to the 5th over x cubed. Right, we are using the formula here. This formula here. Okay, and we can simplify this a little more because 3 of the x's will cancel out. 5 minus 3 is 2. Okay. Okay, maybe do a few more examples. Let me, this one looks good. Let's do 2 to the log 2 of 3x minus 7, and let us simplify this. Okay, so either at the beginning of this lesson, or we definitely mentioned it last lesson, that a raised to the log a of some number, I'm just using the inverse property, so we definitely will be able to use that here. At least it looks like we can use it somewhere. Okay, anyways, we have 2 raised to the log 2 of 3x minus 7. So using the property I wrote in red, 3x minus 7. Okay, and we'll just end this lesson here. So again, all we were doing in this section was just plugging into the formulas here, the addition and subtraction formulas, and we occasionally used the exponent formulas. Okay, so